So here's what we're going to do today. So last time we saw some JavaScript syntax, some basics. We saw how we took things like for loops and while loops and variables and if and else statements that we had been doing in pseudocode, and we saw how to write those in JavaScript. And that was kind of towards the end of the class, and that was pretty quick. But you've had a chance to write a little bit of JavaScript on your own. You haven't used any of the loops or ifs or anything like that in the Code Academy stuff you've done so far, but you did do a little JavaScript. So the first thing we're going to do is just go back right away and look at that JavaScript syntax again, and just refresh our memories around what that looks like. And then we're going to actually put some of that into practice by taking some of the pseudocode exercises that we did in homework and formally translating those to JavaScript. And as we do that, we're also going to kind of take some time and break out and have you write some code as we go in class today. So you're actually coding, getting things to run, getting comfortable during today's lesson. It's not just listening and watching. So you're actually getting comfortable with code. And then after that, towards the end of the class, we're going to introduce some new concepts that we didn't do in in pseudocode at all, but are very, very fundamental, and which, once you get used to them, are going to make your lives a lot easier and are going to be really nice and friendly for you. They're called functions and arrays. These are two foundational concepts that exist in every programming language in the world, pretty much, and which you need to kind of get exposed to pretty early. So we're going to do that. And you're going to have some homework that will give you practice with functions and arrays as well. Okay, so here are the things we talked about last week in JavaScript and what we saw some syntax for. So I just want to go back to those kind of examples that we did last time and walk through them just to remind ourselves. Okay. So variables, remember, are just buckets for storing values, and the values can have different data types. We can have numbers, we can have strings, which are just strings of characters or words, if you like, although they don't have to be words, they can be gibberish. And we can have Booleans. Those are the three kind of main variable types that we talked about. And so a variable holds a piece of data that can be one of those data types. And so in JavaScript, we create a variable by using the var keyword. You put var in front of the name of your variable, that creates a new variable. And you can then set it to a value. In this case, I set it equal to 0. And then once you have that variable, you can then do anything you want with it. You can set it to a new value. I can set it number of quarters equal to 5. I can do math with this one. This variable happens to be a number, so I can do math with this variable and then add 1 to it. And so variables are things that we can use throughout our code. They hold values. We can carry out different operations on them based on their data types. So number variables you can do math with. String variables you'll be able to do like concatenation, joining strings together, printing them out, etc. Something else we looked at very early on in JavaScript is the semicolon. So every statement that we write in JavaScript will end with a semicolon. And I mentioned last week that both of these things, using var and using a semicolon, are technically kind of optional, but you should always do them. So you can write JavaScript that doesn't have a semicolon and doesn't use the var keyword, and this will still run, okay? Now, I didn't say work because it's really easy to mess yourself up and to create confusion by not doing this. So it might not be obvious why that's true, but maybe by the end of the class today, I can give you an example of why you would want to use the var keyword every single time. So just for us, for practice, and for just all programmers in general, it's a good habit to use the semicolon and var. In other programming languages, most other programming languages aren't this forgiving. And so, for example, if you're writing code in Java or C, which looks very much like JavaScript, if you leave out these things, your code just won't run. So that's another reason to get used to doing it and to build it as a habit, because when you go to another language, you have to do it. It's not an option. Okay. Any questions about variables? Okay, so and then we looked at loops, for loops and while loops. And so these look pretty similar to what we were doing in pseudocode. The main difference is that there's a lot more just stuff. There's a lot more characters in the file, on the screen. And this is because JavaScript has very specific syntax, like all programming languages. So a while loop here, remember while loop has a condition, and the loop repeats as long as that condition is true. This loop is going to repeat as long as this variable number to print is less than 100. My condition is always wrapped in parentheses. So for every while loop in JavaScript, our condition will have to be wrapped in parentheses. And then what we call the body of the loop will always be wrapped in curly braces. And so the curly braces tell the computer that the stuff between them is what goes with the loop. So if I put, say, this line of code that increments my counter, and I put it after the curly braces, what would this do? Yeah, it would be an infinite loop. It would keep going, right? So why is that true? Let's make sure we understand this. I'm going to loop while number to print is less than 100. And each time I'm doing only what's in between the curly braces. So I'm doing only that stuff right there, which is just printing out the number. But I'm not changing that number each time. So the number starts out at 1 the first time I go around the loop. And every time around I print it out, it never changes. So then it never gets higher than 100. Hence, it just loops forever. So that's bad code. And that's because this statement, even though I'm incrementing that counter at some point, I'm not doing it inside the body of the loop. So the curly braces signify code that goes with the loop. Okay. For loop is very similar in some ways, very different in others. So again, we have for with some stuff in parentheses, and we have the body of our loop contained within curly braces. The main difficulty with wrapping your brain around for loops the first few times you see them are all these things in the middle, right? So in pseudocode, we kind of used for loops like this. We said for number to print equals 1 ... 100. That was kind of the pseudocodey way to do that, right? And that's a lot simpler. It's kind of clear what's going on. It says, hey, we got this thing, number to print, it's a variable, and it's going to take on every value from 1 to 100 as I loop around, okay? That's kind of conceptually, intuitively pretty clear. This JavaScript, line 32 here, this loop is doing the exact same thing, but it's not clear that that's happening. So there are 3 components of a for loop, and actually, conveniently, they're in the comments here. Let's look at these 3 components and see that these are the same thing, that in effect they're doing the same thing as the pseudocode JavaScript. Or sorry, the pseudocode for loop. The first component of the for loop, the thing before the first semicolon, is going to initialize your counter. Okay, so you need a counter for your for loop. It's going to initialize your counter. So it's going to say, make this new variable that's going to be my counter, and make its initial value equal to 1. Okay, most loops, we'll see later on, most loops we write are going to be initialized to 0. Our counter is going to start at 0. We'll see why that's the case, but right now for this one, it starts at 1. That's okay. So our counter is going to start at 1, right? Which is kind of the same thing as what this is saying in pseudocode. It's saying, hey, here's my counter. The first value of my counter is going to be 1, right? The second slot in the for loop, the guy in the middle there, is the test condition. So just like similarly to what we do in a while loop, every time a for loop goes around, there's a test condition that's checked. The while loop continues to loop as long as our test condition is true, right? For a for loop, we have a similar situation. This test condition, our for loop is going to continue as long as that test condition happens to be true. In this case, our test condition is number to print less than 100, less than or equal to 100, actually. All right, so that's kind of like saying this part of the pseudocode, that we're going to go up to 100. We're going to start at 1. That's what this part says, and then we're going to go up to 100. We're going to continue as long as we're less than or equal to 100. The third slot in a for loop is what we call an update or an increment. So every time the loop goes around, it's going to run the stuff within the curly braces. And before it goes back to the top to do the loop again, it's going to do this little thing right there, the number to print plus plus. What does plus plus mean again? Do we remember that? Adds 1 to that variable. It's just a shorthand, okay? So it's not meant to be confusing or anything. It's just a shorter way to say add 1 to this variable, Okay. You can also do minus minus, which would subtract 1 from that variable. Yes, in the back. You can't use that notation. You can just say number to print equals number to print plus 2. You would have to write it as a longer way. Yes. In this one, the counter will go to 101. That's correct. When it gets to 101, though, what happens? I get to this check, and I run that test. I say, is 101 less than or equal to 100? And it says no. And so that's when it quits. It doesn't actually, that last time when that check fails, it doesn't run the body of the loop code. It skips it. In this case, this won't print 101 because I'm not adding 1 until after I print. I can walk through that in a little more detail if that's still not clear. Does that make sense? Not quite? Okay. I asked myself for a mentor during one of our first breaks, and we can walk through that. Any other questions right now? Okay, so the for loop, we said the last slot, this little thing is going to run kind of like, it's going to kind of serve this role in the while loop. It's going to run at the end of the loop before I go back to do it again. Now, the nice thing about for loops is once you get used to reading them, you can just look at this really quickly and say, this is going to loop from 1 to 100, just like that. You're just going to get used to the syntax and get used to these different parameters. And indeed, most for loops are going to look something like this. So a lot of people, most people will use eyes in a lot of situations for the for loop counter. And so this is what most for loops, and indeed a lot of the for loops that we'll write, look like. This is just a little bit shorter, right? It looks a little bit cleaner. There's less stuff to kind of decipher. And that's just going to say, go from 0 to some maximum value that I haven't really specified. But this would be like a number, like 100. And that loop's going to go around 100 times. Okay? It's going to start out at 0. And then it's going to add 1 to that counter each time until the test condition fails. And then that's going to be when I equals 100 is when that test condition is going to fail. Okay. Any questions about for loops and the 3 slots and kind of how that works? So a little bit more syntax, but in the end, simpler in some ways too, because I don't have as much junk to put before and after and in the body of my loop. Okay, cool. So the last piece of flow control we saw, these things are all referred to as like flow control because they're points at which your code is making decisions, right? Loops are repeating things, they're making decisions, they're evaluating things, they're testing conditions. The last piece of flow control we saw was if else. And so here's the syntax for if else. We have if some condition within parentheses is true, then I'm going to run the code within the curly braces that follows the if. Else, I'm going to run the code that falls between the curly braces for the else. Okay? And again, just like in pseudocode, we don't have to have an else. We can just say, if something is true, do this. We don't have to join that with an else. But this was the absolute value example we saw, right? So this tests a number, says x. If x is greater than or equal to 0, we're going to print out just x because x is its own absolute value. Otherwise, x is a negative number, so we need to reverse the sign of x before we print out to get the absolute value. Okay, any questions about if else, loops, any of this syntax? Cool. We're going to do a few of our pseudocode examples and translate those to JavaScript. So let me find one of these. Let's take exercise 4. Exercise 4, here was the answer to exercise 4. It was to print out all numbers between 1 and 50 that are even. Okay, so for this one, I created a variable called number that's just going to go from 1 up to 50. Each time I go around in my while loop, I add 1 to a number, and I'm testing. My test condition here is that I'm going to continue to loop as long as number is less than or equal to 50. So as long as that number is less than or equal to 50, I'm going to continue to loop. All right, so once I'm inside my loop, what do? I first have to check. See, this comment here is checking to see if my number is even. It's a nice note to myself. It says if number %2 equals 0. What does %2 do? Number %2? It does modulo 2, which takes the remainder after dividing by 2. So if the remainder is 0, that means my number is even. If the remainder is 1, that means my number is odd. So if number mod 2 equals 0, that means I have a number, an even number, and I'm going to print that number. Okay, then I add 1, and I go around again. Let's translate this to JavaScript. Okay, so we're going to do a while loop. So I'm going to set up my while loop. This is in place there. I've got while, condition, and braces for the body of my loop. And what's the first thing I need to do here? Let me move this over here. Right, so in our pseudocode, the first thing we did was we had a variable. We had variable number. So I'm going to do the same thing over here. I'm just going to say while var number equals 1, semicolon. Our pseudocode, the condition was number less than or equal to 50. That can basically still be the same thing. I need to get fancy here. Some parentheses, that same condition will work. Now, what's the body of my loop? Here I had 2 pieces to my body. I had this if statement, and I had the increments. So I add my comment here. Or not prints. Increment number. So let's do the easy part. Number equals number plus 1. I could also do this. A little fancy. Number plus plus. Same thing as number equals number plus 1. Okay, so my if statement here, I need if something is true. I want to print my number. In JavaScript, we print by saying console.log number. I'm going to do what for my check? If the number is even, means I'm only printing if number modulo 2. And how do I say number modulo 2 is 0? In pseudocode, I said number modulo 2 equals 0. I just used the English word equals and put 0 after it, and that like made sense, and it was fine because it was pseudocode. This is something we actually haven't seen in what I've shown you from JavaScript yet, so I wouldn't expect you to necessarily know the answer. I want to say equals 0, but this isn't going to work, okay? I need equals equals. Okay, so the reason why a single equals doesn't work in JavaScript is because the computer sees an equals here. And where else have we seen an equals in our code already, right? Right there, line 3. What is that equals doing? It's setting a variable to be a value, right? It's assigning a value to a variable. So it's a single equals means assignment. It means take this thing, make it be this value. Are we trying to assign any value in our if statement? No, we're asking a question. So we don't want to use single equals because single equals means assign this value. We're going to use double equals. That is the check. That's going to test to see if number modulo 2 is equal to 0. So double equals means check for equality. Okay. That's our while loop in JavaScript. Any questions? Yes. That's kind of complicated. It has to do with, I mean, you can use triple equals in this case. It's going to be the same, more or less the same thing. It has to do with data types and what's called rigid typing versus dynamic typing and stuff that we're kind of not capable of fully grasping yet. Triple equals, just to give you a quick example, you can say false equals 0, and that should be true, even though they're different things. If they're triple equals, that is not true. So. Okay, go for it. That's great. Yeah. The closed bracket is right there. Yeah, so we can have brackets like nested. The computer has to like figure out which brackets go with each other, right? So see how when I just this code editor I'm in, like across line 13, it highlights the top one. That's just telling me, hey, these two match together. Now, if you mismatch them, you're gonna have a problem. Like, so if I did something like this, and I forgot to put that there, I'm gonna get confused, and it's gonna say, hey, that closed bracket goes with that one up there by the if, which is not correct, and my code's not gonna work right. So yeah, you can't have brackets nested within each other as long as they're, and this is important, this is why I'm indenting things the way I am, so that visually I can look at it and kind of see which things go with each other. JavaScript doesn't care that much if you indent or not. It just, it's easier for us as programmers to keep things nice and clean and to do it that way in order to make sure our codes are readable and we're not making mistakes. Any more questions? Okay, so let's see. One more maybe. For loop. We'll do this one pretty quickly, and then we'll do an exercise. So exercise 6, one of the ways you could do this was to print all odd numbers between 4 and 40. And you can do this with a for loop. Let's do that this way. Make a comment, so it kind of describes what I'm doing. A good practice is as you go is to write a comment and then write a line of code or two. That way it kind of helps keep your thoughts organized. So I'm going to say for, have some for stuff in there, and then I'm going to have some stuff within my body. Now my for loop should go from the numbers 4 up to 40. So I have 3 pieces of my for loop. What's the first one? I have to create a counter variable. Create my counter variable I, and I want to start at 4 actually. So let me say initialize it to 4. So my new counter variable I is equal to 4. The second condition is going to be the test condition. It's going to be what I'm checking for each time around. And so I want to continue to loop as long as I is less than or equal to 40. Right? And then each time around, I'm going to add 1 to my counter. Set up my for loop. For var I equals 4, it's going to start at 4. It's going to keep going as long as I is less than or equal to 40, and each time around, I'm going to add 1 to my counter. Okay, and so now I want to see if I is odd. If, how do I say if I is odd, I'm going to print it out, right? I would check to see if I is odd. Similar to the even one, right? The only difference is modulo 2 should be not 0, but 1. So if I modulo 2 equals 1, or equals, then I'm out. Okay, so pretty similar, right? A lot of similarities between those different lines. Any questions? Yeah. You could say if I modulo 2 is not equal to 0, that would be the same thing. In this case, that's because when you're doing modulo 2, it can only be 1 or 0. If you're doing like 3 or something, you couldn't do that. It would be just because there could be 1. It could modulo 3 could be 0, 1, or 2, right? Yeah. Any other questions? All right, so we're going to do some practice. So the first one, you're going to do this on a site called jsbin.com. So let me show you first. Let me give you a little tour. Go to jsbin.com in your browser. Give you a little tour of JSBin. This is just a little environment that we can play with JavaScript and run some JavaScript. And there are lots of ways you can write JavaScript, lots of places you can do it. This one's simple because you don't have to install anything. It's just there. This website's always there. If you want to toy around with some JavaScript, it's a good place to go. So you go to jsbin.com, and let me just refresh. Actually, that's not going to work. Let me do this. This is when you first load the page, it's going to look like this. Oh. There we go. It's going to look like that. Okay. So we want to kind of customize this a little bit just so we can get stuff out of the way that we don't want to look at. Notice these 5 kind of little buttons at the top: HTML, CSS, JavaScript, console, output. These are just going to, clicking on those will toggle on and off 5 different panes. We only need a couple of those panes. The ones we see currently, on the left, there's the HTML pane, and on the right is the output pane. We're going to turn off the HTML pane. We're going to turn off the output pane, and then we're going to turn on JavaScript and console. Okay, so once you do that, you'll be able to write JavaScript on the left, and then you'll be able to run it, and whenever you print stuff, it'll show up on the right. Okay? Is everybody there? Any questions? So let me just run a piece of the JavaScript we just wrote. So JSBin is telling me to use cool. So you might get little warnings down there. Don't worry too much about them right now because JavaScript is like a funky language, and it's just focus on your code, running your code, and the output. So here to run it, I just click the run button, and it prints out all the odd numbers between 4 and 40 on the right-hand side. And you can clear the console output by hitting clear. So if you run it and it doesn't work the way you want to, before you run it again, you might want to clear. Okay, so you can write code in the left, run it, stuff gets printed out on the right. The first thing we're going to do is just to write a for loop that prints the numbers 1 through 10. Okay, so I want you to do, this is simpler than the exercises we've been doing because we've been checking even and odd, but I want you to write this loop and do it yourself and print it out. So go ahead and do that. I'll give you a few minutes to do that, and make sure you get this. If you're not getting it, raise your hand, and myself and our mentor will help you out, okay? Anybody that's not connected to the internet, raise your hand. We're all on? Awesome, cool. Just another minute or two on this one. If you're getting stuck or you're not making progress, raise your hand and somebody will come around and help you out, okay? All right, we're gonna go ahead and continue now. Sorry, I didn't mean to confuse you there by changing the slide. We're gonna walk through this one. So if you didn't quite get it, follow along with me now and make sure that your code runs as we're typing along. Okay. Let me see if. Better. Okay. Okay, so we want to, again, just to restate what we're doing, we're going to write a loop that prints out the numbers 1 through 10. So a for loop, to be specific. So to set up our for loop, for my ends, my braces, I'm going to set it all up, so I don't forget them. And hold on, there's a setting here. Okay, there's like an auto run setting that it's not showing me here. There it is. Okay, sorry. All right, so I've got my for loop set up. I've got 3 places within my for loop. So the first thing I do in my for loop is I create a counter variable. So my counter is going to go from 1 to 10. So I'm just going to say var I equals 1. Second spot in my for loop is going to determine how far my loop goes, how many times it runs. So it's going to, this is going to be a test condition. So I'm going to continue to loop. If I want to loop from 1 to 10, what's a valid test I could put here? I'm going to keep looping as long as I is what? Less than or equal to 10. Another way to do it, and this is the way most programmers are going to do it, is use less than 11. Same thing. But now we'll see this one. This one kind of seems more natural in this setting. And then each time I go around, I'm going to add 1 to I. Now, I++ is the one I'm going to recommend that you do this. Some people had tried to do this, I+1, and this doesn't work. And this is kind of, I want to walk through this because this is an important lesson. Why does I+1 not work? So let's just say, let's kind of go down here and do some scratch work. Okay, so if I'm going to say, you know, if I is equal to 2, and I say I plus 1. What JavaScript is going to do, what the computer is going to do, is it's going to turn that into the expression 2 plus 1, right? 2. So I can just kind of substitute those. 2 plus 1 is what? 3. Now, it's going to make that computation. It's just going to compute 2 plus 1. It's not going to change the value of anything. It's not going to change the value of I. It's just going to compute that value, 2 plus 1. So it's, if I want to actually change I, if I want to actually add 1 to I would need to say I equals I plus 1. Then that would say I equals 2 plus 1, which would then be 3, right? See the difference there between assigning and just computing? So this right here is going to, each time around, it's going to take whatever value I happens to be and add 1, but it's not going to update I when it does that. So there's 2 things you can do. You can either do this, and say change I each time you go around, or you can do the plus plus. It's a little bit easier, like it's harder to screw up. So that's what I'm going to advocate that you use. Cool. Any questions about that? Why those 2 are different? Why it doesn't work to just do I plus 1? Great. Make some around. Out my number. And let me clear it first. There we go, 1 through 10. Cool. So if you're typing along, I'll give you a couple seconds to finish up and make sure you can run that. And if you can't, raise your hand and a mentor will come by and help you get that for loop. So one of the lessons we learned here, a lot of you who had questions had a syntax error, right? So that meant that you had some kind of detail with your code syntax wrong and things just didn't work. So you might have had the right kind of logic, like you might have had things in the right more or less place, but you forgot a semicolon, or you used a comma instead of a semicolon, or you forgot one of your parentheses. Those things are all crucial. The computer needs those things in the right places to run, or it's going to choke. It's not going to know how to understand your code unless every one of those details is in the exact right spot, okay? Cool. All right, so we're going to go on to, we're going to do one or two more of these, probably just one more. Let's do, okay, let's do this one. So go ahead and we're going to, you can wipe out your code if you want there, and we're going to write another for loop. And this time we're going to write a for loop that prints out all multiples of 7 between 1 and 100. Okay, so we've done stuff similar to this, right? So you've got all the pieces you need. You just need to remember exactly which pieces we've used before that are relevant and doing those in your own code now. So take a few minutes to do that and raise your hand if you get stuck. Also, we're not going to take like a formal break during this, so if you need to use the restroom, get a drink of water, whatever, go ahead and feel free to do that. just another minute or so on this one. If you're close but not quite there, go ahead and raise your hand, and I'll come by and help you. All right, let's walk through this one. So our task was to write a for loop that prints all multiples of 7 between 1 and 100. So this is going to combine for loop, which we did in the last practice problem, with an if statement, which we haven't actually written in JavaScript yet. So let's go to our JS bin. I'm going to clear my console and delete all my code. Okay. So we got a for loop. So I'm going to go ahead and set up. This is my for loop. I'm going to go from, let me remind myself, 100. What we do is to say var I equals 1. I check, we go up to 100. So I can say I less than or equal to 100. Got a few questions about spacing. Those two are the same. I can have spaces between my variable, the less than or equal to, and then the 100 or not. It doesn't matter. You might decide that one's easier to read. I would be consistent in your coding. It's going to make it more readable. You might decide that you like spaces. You might decide you don't like spaces. But it doesn't matter to JavaScript. And then I'm going to go and add 1 to my counter each time I go around. So that's the setup for my for loop. I'm going to loop around 100 times, going from 1 to 100. And then what am I going to do each time around? This one's a little bit more complex, so I'm just going to add a comment to kind of help myself understand what I'm going to do. Each time I go around, I is going to be successively equal to 1, 2, 3, 4, etc., all the way up to 100. And I need to check to see if I is a multiple of 7. If so, print I. Okay, so that's what I'm going to do. All right. This is still auto running. I don't know why. Okay. So how am I going to check that? I'm going to need an if statement. If something is true, I'm going to print out I. And that something is if I is a multiple of 7. How did we, the similar situation we've seen is determining whether or not I is even or odd, right? Even or odd just means is a multiple of 2 or is not a multiple of 2. To say I was odd, or even rather, that meant that I modulo 2 was equal to 0, right? So what's the corresponding thing to say I is a multiple of 7? I modulo 7 is equal to 0. That means I is a multiple of 7. Okay. Follow along there? And that's it. So I'm going to print out. Let me go ahead and clear and run. And I get 7, 14, 21, 28, all the way up to 98. Sure enough, all the multiples of 7 between 1 and 100. Okay? Any questions about that? Yes. Say it again. You could do that, yeah. Yeah. So all she's saying is that I could start my, since I know there are no multiples of 7 between 1, 2, 3, 4, 5, 6. None of those are multiples of 7. I know the first multiple of 7 is 7. You can just start at 7. That's another way to do it. That's what you're saying? Is that right? Yeah. Any other questions? Yeah, in the back. So you got to be careful. You can do that. I plus 7. You don't need to check anything. So you can do that. Make sense? Yeah. So remember, like, I think on the first day I said that, or maybe the second day of class, that there are multiple ways to do any of these things. So just because I do it one way doesn't mean that it's the only right way. Yeah. Again, this is kind of a subtle point that we're not totally going to understand because we don't have the full background. Double equals will say, like, if things are different data types, so you've got like false and 0. False is a Boolean, 0 is a number. Double equals will compare things of different data types to each other, where triple equals won't. Okay, so JavaScript is weird. Most languages aren't like that, so it's kind of screwy. All right, how we doing? Good. I'm sorry, power strips? Yeah, so back by the TV, right under the TV is a blue crate with some power strips in there. And all of the black wells in the floor have power in them. All right, so now we've gotten our feet wet with some basic JavaScript syntax. So we've actually run some code for the first time. Actually, you did some in your homework too. Some people, not the first time, but we ran some loops. You didn't do any loops in your homework. So this is all kind of new stuff. So we're going to add some new tools to our tool belt. And we're going to talk about 2 new concepts for the rest of class. And these are going to be functions and arrays. So functions, if you go back to the first day of class, one of the things I said that computer programs let you do is I said that they'll let you repeat things in very efficient ways. They'll let you take one piece of code and use it multiple times other places. Okay, does anybody remember something like that being said? That's what a function is. A function is going to be a chunk of code that we're going to kind of wrap with some special syntax to say to the computer, hey, this is a function, this is special, and then I can use that code other places. I can use it one other place, I can use it 1,000 other places without having to rewrite those lines of code again and again and again. So similar to the way that loops help us do things efficiently, they reduce the need for us to repeat ourselves. Functions are going to be the same kind of thing. So there's this principle in coding called DRY. DRY, it's just an acronym for don't repeat yourself. You find yourself like doing very, very similar things in your code. If you write a line of code and then a minute later you're writing something that's almost identical, and then a minute later writing something that's almost identical, ask yourself, can I do this with a loop? Can I do this with a function? Okay, so if you find yourself repeating yourself, that means there's probably some efficiency to be had there. So a function, let me go back here. I think I have, yeah. So here is a basic example, kind of our hello world example of using a function, just to introduce the syntax. So if I want to create a function in JavaScript, well, first of all, let me say that if you look at online documentation and stuff, you'll see people creating functions in slightly other ways. JavaScript is a very, very flexible language, and it will let you do things in multiple ways. So if I say this is the way to create a function, and you go online and look up JavaScript function documentation, and you see somebody else doing it slightly differently, it's not that I'm a liar, it's just there are multiple ways to do the same thing. Okay, so since we're still learning these things, and these things are all pretty new, we're going to stick to kind of single conventions most of the time. Okay, to create a function, I define it by just using the keyword function, and then hello, in this case, is going to be the name of my function. Hello says, I'm naming this block of code so that when I use it later, I can refer to it by the word hello, and that's how I know to come back and reuse this block of code. All right. What's in parentheses there after the name hello is what we call a parameter. So in this case, it's name. Name is an input parameter. It's some information I'm going to be passing into my function. My function, you can write functions that don't need input. You can write functions that need one piece of input, 2, 3, 4, 5, 15 pieces of input, you can do those any way you want. But in this case, my function requires one piece of input. In order for it to run, I need to give it a piece of data. I need to give it a variable or a string or something when I call it. And in this case, I'm going to call that name. Now, the curly braces, just like with loops, they say everything between these two curly braces goes with this function. Everything in between those two is part of the function itself. All right, so in this case, my function just has one line of code within the body of itself. And that one line of code is a console.log. And this is something we haven't talked about. I think we talked about it last time. Yeah, we did. What is, so console.log, we know what that does. That prints something. What's happening between my two parentheses there? Right, so I've got a string hello space plus when I put plus between two strings, it just mashes them together. It concatenates them or joins them. Those are all kind of synonyms. So by saying I have this string hello space and after that name, it's going to take whatever name is. I don't know. I'm writing a function, so I don't know what name's going to be. When somebody calls it, they're going to give me a name. And then my function is going to run and take whatever they give me and put it in place of that variable. And it's going to print out hello space name, whatever they gave me. So let's go ahead and do this in actual code and just see how it works. So I'm just kind of quickly replicating it. Okay, so there's my function. Now, let's run our code. Well, nothing happened, right? Is that a surprise? I have, well, it's true. There's something a little bit more to it than that. I haven't assigned anything to name, but this is just the definition of a function, right? I'm not supposed to, I don't want to hard code a name in there because I want to be able to call it with different names. I want to be able to say, hello, John, hello, Chris, hello, Susie, whatever. So I don't want to assign something to name in the function. To actually use a function, I have to call it. Okay, so this is definition. Defining a function doesn't actually run the code that's part of that function. It just creates the function. All right, it doesn't do anything with it until you explicitly say, hey, computer, go run my function. So I'm going to do that right now. So that one right there. We'll run the function or call it. So the terminology we use in programming is calling a function. You can say run sometimes too, but people will more often say call. They'll say, here's this function call or call this function. Call just means run it. So by saying, remember I said that hello is the name of my function. To use it, I just refer to that name, hello. Notice that this is case sensitive. If I put I can't use a capital H there or anything like that. It's going to get confused. I have to use it exactly the same way. Find it. So I'm going to refer to my function, and I'm going to say hello. And when I call it, I need to tell it what those parameters are, what the input parameters are. This function says, hey, I've got one input parameter. When somebody calls me, they have to tell me what name should be. I can't run unless I know what name should be. So when I call my function, I just have to tell it, make name equal to Chris. Okay, and let's see what happens. Oop, I forgot my space. There we go. All better. Cool. I can also say, hello, Zach. Run both of those. It's going to run the first one and then the second one. I can also do something like var variable. I can call the function with my variable. See? And then it takes the value of that variable, inputs it into the function, runs the code. And so now notice that I've done the same thing 3 times, but I've only really written that one console.log. That one line of code is getting repeated 3 different times. So this is a simplified, there's only one line of code. It might seem a little too simple to care that much about. But if you're writing complex code that is 10, 20, 100 lines of code, and you need to do that thing again and again and again, by wrapping it in a function, you'll allow yourself to then repeat it without repeating those lines of code in your file. Any questions about what's happening here with the function? Yes. That's just how, so the question is, why is it printing off the quotation marks? This has to do with just the way the console works. So that's just the console's way of saying, hey, this thing's a string. If I go over here and I say log 5, that without quotation marks, which is to say, hey, that's a number, not a string. Good question. Any other questions? Cool. All right, let's see, let's write a couple of functions here together doing things we've more or less done in class before. So I'm going to copy and paste these so that you have them for your notes. I put them online. Notice now that I'm in my code editor here. So before people asked, where should I be doing my pseudocode? And I said, it doesn't matter. You can do it in Microsoft Word. You can do it in Notepad. You can do it in TextEdit, whatever. When you start writing code, you'll want to, we're going to be doing all of our coding in Codecademy, but when you start writing code elsewhere, you'll want to write it in what's called a code editor. Notice one of the things that I get here is, see how the code here is nicely highlighted different colors? It's pretty helpful, right? It's a lot easier to read than, say, pseudocode, which is just all white. So all code editors will do this. It's called syntax highlighting, and it's just going to highlight different things in different ways. So a keyword is highlighted in yellow, right? Notice that up here, for, if, var. I've called these things keywords because they're special words to the computer, to the programming language. Those are going to be highlighted in yellow. So it's just a visual signal to say, hey, that's a keyword. That's a special thing in JavaScript. My numbers are all kind of this like peachy color. My input parameters, my variable or my function parameters are blue. Strings are green. This function is red. So these different colors help us kind of visually see what's going on. They'll also help you find mistakes. Like if I said var 4, 4 is a keyword and I'm not supposed to do that. So by seeing it highlighted there, it's a visual indicator. Okay. An absolute value function. I'm going to do this again over here, and then I'll copy and paste it back. So, right, so first thing I do when I write a function is to get the word function. Absolute. I can name this whatever I want. Everything's case sensitive again in JavaScript and every other programming language for that matter. Absolute value. Do I need to, this is going to take the absolute value of some number. Do I need any input parameters for my function? Yeah, it needs a number, right? If I want to take the absolute value, you have to tell me what that number is before I can tell you what its absolute value is. So I'm going to I dictate that my function needs a parameter by putting it between the parentheses. Let's call it num for short. Okay, so a number that I'm going to take the absolute value of is num. We saw this example back earlier in the day, right? Where was it? It was here. So this is basically what I was doing with my code in JavaScript to take the absolute value. Here I was printing out the absolute value. So I don't want to copy and paste this code because I might get myself in trouble because there's different variable names. I'm printing here instead of calculating. So I'm going to kind of rewrite this as I go just to make sure I don't screw it up. But I want to kind of note what I've done here. First is I check to see if the number is positive. If it is, then I know that the absolute value is the same as the number itself. If it's negative, then I know I have to reverse it. Okay, so I need an if. And if num is negative, get some comments there to just guide myself as I go along here before I write code. So if it's positive, I want to return the number itself. So I said return. This is a new concept, all right? So I'm going to type this out, and then I'll tell you, explain what it's doing. Return num. So we actually can run this function now. It's not totally finished, but I can go ahead and run it. And I'm going to do that just to illustrate what's going on. So if I want to run this function and say absolute value of some positive number, return here is a special keyword, okay? And so what it says is, it says when you call this function, we're not going to print anything. We're going to do some calculation and hand back some data to the user, right? They might not want to print it. They might not care about printing that information. They might want to use it in a different calculation. If I just print it, it's gone, right? It goes out to the console and disappears essentially forever. But the point of calling a function is to often to do some calculation that we can use the value of. So variable called abs5, just being for brevity here, absolute value of 5, and then it's going to be the result of calculating the absolute value of 5. All right, so I haven't printed anything. So if I run this code, it looks like nothing's happening. It actually is. It's happening in the background, but I'm not seeing anything on the right because I don't have any print statements. Okay, so let's just go ahead and print. I'm just going to print out the result of my calculation. Okay. The absolute value of 5 is 5. So the difference between printing and returning within a function will take that value and hand it back to the user. So when I say when I call my absolute value function here, it's going to take the number 5, pass it into the function. So at that point, num is going to be equal to 5. It's going to come down here and check and say, is 5 greater than or equal to 0? Yes. Okay. Return num. What that does is it hands back, you can think of it as substituting this little function call with that value. It hands back the value that we calculated to the user so that they can then use it later on and do whatever they want with it. Okay? It's a kind of a confusing concept at first a lot of times. So does that make sense to folks? Is it confusing? See what's going on? Yes. Sure. Mm-hmm. Yeah. Any questions about that? What's happening when I return something? Okay, let's go up and finish our function. So I've already checked to see if, to deal with the case that the number is positive. Now I need to deal with the case where it's negative. Else, I want to, the absolute value of a negative number is the opposite. So I want to return sum. Now, if I go up here and try to call my function with a negative number, see what happens. Okay, so I call my function with, and let me just go back and separate these for clarity. Okay, so I create a new variable called answer. I call my absolute value function on the number -5. When that runs, it goes to the top, it does its check, finds out that the number is not positive, it's negative, so it returns -5, which is 5. It takes that value, it returns it, which means handing it back to the person that called the function, puts it in that variable, and then I print it out. Okay? Any questions so far? Is that clear? Are we cool? Or are those blank looks of confusion? Mostly okay. It's a little weird. Returning is a non-intuitive thing at first. One more thing I want to illustrate. When we return something, let's do this instead of return. Let me do this. Notice what happens when I run this code. I have inside my function, I just added a line that just prints out the word hello, but that doesn't happen when I run the code. Hello never gets printed out, even though I'm calling my function. This is because when you run a function and you hit a return statement that says, I'm done. I've got my answer. I'm going to give it back to the user. Finished. Nothing else to do, okay? So when you write a return statement, know that that's quitting your function when you do that. It's signifying to JavaScript that you've got the answer you want. You're going to give it back to the user, and you're stopping. You're not going to run anything after that. So this line of code never gets hit because I return the answer right there. Does that make sense? Okay. So notes, and we'll do one more function example. Arrays. All right, max function. So let's write a function that calculates the maximum of two numbers. So I'll call my function max. Now I need to calculate the maximum of two numbers. What kind of input parameters do I need? I need two numbers, okay? So I need to say in my function definition, I need two numbers. I'm just going to call these x and y. Notice I'm not putting var here. That's not correct. That won't work because I'm not creating a variable. A function input is different from a variable. And it's a subtle difference, but they are different. So when you write a function, be aware of that you can think of an input as a variable, but they're really not exactly the same thing. So two inputs to my function, x and y, and I want to calculate the maximum of those two values and then return that value, return the biggest, say return the max of two numbers. Okay. How might I do this? I don't think we've done this example, this algorithm in class yet, but it's not too dissimilar from things we've done so far. How do I approach this? I've got two numbers. How do I figure out which one's bigger? You need some kind of greater than, less than, something or other, but what am I going to do? How am I checking? What am I doing? So you could use a third variable. There's an even simpler way, though. So there's kind of two situations here, right? Let's kind of break it down this way. If I've got two numbers, there's two possibilities. X could be bigger. Actually, three possibilities. X could be bigger, Y could be bigger, or they could be the same. Right? Those are the three possibilities. So if X is bigger, let's write down these three possibilities. So guide our code. If X is bigger, then I know I need to return X, right? So I just basically said, what we need to do. If X is bigger than Y, the answer is X, so I return X. Okay. If Y is bigger, then I know that I need to return Y. And finally, if I've gotten down here to the else, that means that both of these top two conditions have failed. It means that X is not bigger than Y and Y is not bigger than X. There's only one thing that can happen, which is that they're the exact same. It doesn't matter which one I return, right? I can return either one. They're the same. Okay. All of that. What's something I can really easily do here to make this shorter? I'm repeating myself, right? I've got two places where I say return X, right? So there should be a way to kind of improve this to make it shorter. Somebody tell me. Yep. So I heard a few people say this. I can do that, and then I can get rid of this because I'm dealing with the case that they're the same in the first if. Okay. Now, yet another thing I can do to make this shorter. I don't need else if. I just need else. Because if X is not greater than or equal to Y, that means that Y is bigger than X. I don't have to check, I already know. Okay? So that's our function. Let's go ahead and try it out a couple times. I'm going to print out the maximum of 2 and 3. 3, that's good, right? Say the maximum. So here's just kind of a first lesson in testing your code. When you write a function or anything, you want to run it and see if you did it right, okay? There's no way to know without a doubt that your code is always like 100% correct, right? I mean, like you can look at if it's simple enough, you can look at it and kind of like go through the different possibilities and whatever. But this is actually a computer science theorem that if I give you just like blindly say, hey, here's a function, tell me if this function does what it's supposed to do, there's no like foolproof way to check that. So generally, the way we test code is we test with lots of different types of conditions. I just ran and said, hey, my maximum of 2 and 3 is 3. I don't want to quit there because there's other potential situations that I could run my function under that might not work, right? I haven't given it a negative number. I haven't given it a decimal number. I haven't done any number of things. I haven't tried it when the numbers are the same. There's so many different ways that I could screw this up that when I'm testing my code, I don't just want to quit with the first time I test it and say, oh, good, I'm done. Because there's so many different ways that you could go wrong with something that you need to test as many different possibilities as you can think of. So let me say -2 and 3. All right, that works. What about -3? Good, right? I can test. I just said another way to do it would be to test if they're the same. Let's see if that works. Okay, that worked. What's another test case? Tested, they could both be negative, right? Let me try that. -1, -2. -1, that's correct. What's another test case? Decimals. So let's say 1 and 1.01. Cool. That's pretty decent. Let's call that a day. That's a good different, notice what I've done is I've just thought of like different situations where something might have gone wrong. Now this is again a simple function, so you might say, hey, I can look at that and know that it's okay. But pretty soon you're going to be writing code that's much more complex, and just looking at it or just trying one or two different test cases isn't going to be good enough. So always be thinking about what are the different situations in which somebody might use my code. Okay, so that's functions. We good? All right. So now we're going to introduce a new concept called arrays. And I forgot my iPad, so I'm going to write on the whiteboard. If you guys can't see this in the back, just let me know, and I'll write bigger and darker, okay? Okay, so now we just want to actually play with some arrays in our code. Let me just kind of reiterate, I can do a few different arrays to play around with. I can create a number array as, say, 1, 6, 13, 27, and 5.6. This array now has things 1, 2, 3, 4, 5. It has 5 items, so you can use index 0 through 4 there. Her question was, can I have another box? Yes, you can. I can say num array 5, so I've got indexes. The last thing in my array is in index 4, so I can say num array 5 equals 127. Now my array will be equal to that. I've just created another box. No, you can do array with nothing in it. I can say our empty array. We'll do that. It seems like, why would I do that? But you will do this quite often because you'll fill it with things later. Okay? So it's actually pretty useful. I can say var string array. I can create an array of strings. So we got Delmar, LaunchCode, CWE, Central West End, strings there, and I can create arrays that are mixed, that have multiple types of things in them. So 4811, Delmar, 63108, that's our zip code. Park. That's a mixed array. One other thing, I said you can think of arrays as like a new data type. It's like our 4th data type that we've learned so far. We've learned about numbers, strings, booleans. Array is a 4th data type, which might make you think, if you think like really creatively, you might say, can I put an array inside of an array? Sure, you can do that. So I'm not going to do that example. You can try to play around with that and try to see how that might work yourself, but you can do that. You can put arrays inside of arrays. Okay, so let's print out, let's write some code to print out an array. And before we get too far, I'm going to move to JS bin so we can run our code. All right. Let's print out our number array first. So, well, let's just do a couple kind of warm-ups. Our number array, how would I print out, if I just wanted to print out the first thing in my number array, how would I do that? So using the bracket syntax we learned over there to get the first thing out, what index does the first thing have? It has index 0, and I use the bracket syntax to get it out. So I'm going to say num array bracket 0. Okay, run that, and it prints out the number 1, which, yep, first thing in my array. If I wanted to print out the third thing in my array, what would I do? So third thing has index 2. 13, is that right? 1, 2, 3, yep, that's right, cool. Okay, so I could just do a bunch of console.logs. One way to solve my problem. say out 0, print out 1, print out 2, print out 3, print out 4. Cool. All right. Seems okay, doesn't it? What's wrong with that? They're not necessarily wrong, but not so great. What's the acronym we learned? DRY. Don't repeat yourself. I've just done basically the same thing 5 times. There's only one little minor difference between each of those 5 lines of code, and that is what? It's the index. So what might I do to fix that? Any ideas? So I've got different things I can do. We've learned that ways we've learned to not repeat ourselves. Function is one way we've learned to not repeat ourselves. What's another way we've learned to not repeat ourselves? Loop. We can also write a loop. And those aren't interchangeable, by the way. So there is a right way to do this one. And in this case, it turns out we actually want a loop. So I don't want to do this. I want to be able to say, have some way of writing a loop. What kind of loop? We think we've got 2 kinds of loops, for and while. One is better than the other in this case. So actually, it's a for loop. And the reason is, when we first introduced for loops, I said for loops are generally better when we know exactly how many times we need to loop, right? How many times do I need to loop this time? I know exactly I need to loop 5 times because I've got 5 things in my array. So a for loop is going to be a little bit better in this situation. Again, you could do this with a while loop, but a for loop is going to be cleaner and nicer. You could say var I equals 0. I'm going to start off at 0 because that's the first index in my array. I'm going to go up to say I less than 5. I plus. So it says I want to loop from the numbers 0 up until just less than 5. So I'm going to do 0, 1, 2, 3, 4. And each time around, I'm going to print something out. Okay, so when we talked about for loops earlier, I said you're often going to start your for loop at 0. This is one of the reasons why, is because arrays start at 0. So you're often, when you deal with arrays, for loops are going to be right there with them almost all the time. Array, for loop, array, for loop. You're going to be using those hand in hand. So the reason why most of the time we write a for loop with starting index 0 is because arrays start at 0. The reason why there's less than here rather than less than or equal to is because it's a little bit easier to read. It says there are 5 things in my array, so I'm going to go up until I less than 5. So what's one, this is not quite right quite yet. What one thing do I need to change to get this to print everything in my array? I need to change my index. So again, something we've done, but so far we've only referred to specific indexes, specific numbers between the brackets, but I can use a variable as long as that variable is a number, okay? My variable I is going to be a number. It's going to be between 0 and 4. It's going to be one, in the right range, so I can do that. So let's go ahead and run this code. So sure enough, I print out everything in my array one at a time. Okay, does everybody understand this? Any questions? This is like pretty important to grasp what's going on here. This is how you're going to interact with arrays most of the time. Okay, so now if I wanted to write code to print out everything in my string array, I could do pretty much the same thing, right? Copy paste, change num array to string array. String array having 3, so I'm going to go for I less than 3. And let's run that. And it printed out all of my strings. Cool, right? What did I just do there that I should not be doing? Copy and pasting. That's repeating myself, right? All right, so let's see if we can find some way to not copy and paste. If you find yourself copying and pasting code, you should ask, can I do this another way? So here, the answer is yes, we can do this another way. And so before, when I said what are the 2 ways we can not repeat ourselves? One was a loop, the other was a function. Here, we're going to write a function. So I need to figure out how to write a function, print out any array. So that's my goal at this point, is to write a function to print out any array that somebody gives me. So let's call it print array. That seems logical, right? What kind of parameters might my function need? If I'm going to print an array, what input parameters would I need for my function? Well, you got to tell me what to print, right? You got to give me an array to print. Some R. And let's see how far we can get here. We're going to get stuck at some point because we don't quite have all the information we need. I haven't given you all the tools you need to write this function, but we can get pretty far. So when I went to print out my string array, I basically copied and pasted this for loop, right? So that tells me that that's probably what needs to go inside my function. If that's the stuff I'm copying and pasting, that's probably what needs to go inside my function. So clean this up, indent it a little bit more. Okay. So now, instead of logging something from numArray, I want to get something out of R. But I'm not quite correct. What's wrong with this code as it stands? Well, I'm looping from 0 up until 5, just less than 5, right? But if somebody gives me an array with more or less than 5 things, I'm not going to actually print out everything in the array, or I might print too many things, right? So I need some way to say how many things are in the array. Thankfully, there's a really nice way to do that. You might here's another decent guess that you might say. You might say, well, what if the person just has to tell me how many things are in the array when they pass it to me? It's not a bad thought to have if you have this thought. So now I input parameters, and now I just know because they told me how many things are in the array. That's one way that you might solve that problem and say, whoever wants me to print the array, they got to tell me how many things are in it. Now that's fine, but it turns out that JavaScript actually has a way for us to tell how many things are in an array. And as a special syntax, you can say r.length. You did this in your Code Academy stuff, right? Remember that? With what? With strings, with your name, right? So you might say, this is different because this is an array, but it turns out, keep learning JavaScript, you learn that strings and arrays are basically the same thing. You can think of a string as a bunch of boxes with letters in it, okay? So just know that we can tell how long an array is by using .length. Here's yet another reason why we use less than instead of less than or equal to. If I have 5 things in my array, r.length is going to be equal to 5. So if I say less than or equal to, and I'm using that as an index, I'm going to go one step too far, right? So that's one of the reasons why we use less than. Okay, now let's just test this out. So I have a function here that supposedly prints out everything in an array. Let's print out some arrays. Let me get rid of this code. Well, I'm just going to comment it out, actually. So just to note what I just did there, I told you to use double slashes for comments. You can also use, that only works if all of your comments fit in a single line. If you want a comment that is multiple lines, you can use /* to open that comment and */ to say this is the end of the comment. Similar to the way that you have curly braces to start and end a loop or start and end a function. /* says here's the beginning of a comment. */ says here's the end of a comment. So I just commented out this code just so it doesn't run when I hit run. So let's test our code. So let's say print array. I've got 3 arrays I can print, right? I've got numArray. Let's see if this works. Cool, that worked, right? Yeah, it worked. Let's try it with string array. It worked too. And finally, I haven't used yet the mixed array with different data types in it. That worked too. There we go. Pretty neat, huh? So I took something that conceivably could have been 10 or 12 lines of code and boiled it down to basically 5. And it's now a function which I can use anywhere I want. I don't have to copy and paste for loops. I can just use this function again and again and again. How are we doing? Any questions about our function, our arrays? So I had one more example I was going to do, but we're pretty much out of time. I think we're kind of losing steam here, so we're going to quit here. If you do have questions about this, ask me or a mentor. This is a pretty important example. Again, I'm going to put all these examples up on the course site. Your homework is in the same place that it normally is on the course calendar. And so let me just make a couple notes about homework. So you're going to go to class 3, homework, and I give you some different groups of exercises that are in Code Academy. So there's a lot of stuff in there. You can do more of them. So for example, I say finish the rest of unit 1, which you've already started. For units 2, 3, and 4, I just give you a certain subset of exercises. You can do all of them in those units if you want to. We haven't talked about everything that is in those exercises, but they kind of walk you through stuff. That's kind of the way Code Academy is set up. So if you want to keep going and learn a few extra things, if you're liking it and speeding through it, feel free to keep going. There are also, for each of these units, there's for each of these lessons, there's like a second unit, which is like creating a program to do something. So one of them is like write a rock, paper, scissors game. There's different things you can do. I haven't given you those as assignments, but if you get through those and you want to write those programs, go for it. Those are pretty fun things to do too. So don't feel free if you're getting through this stuff. I don't know how long it's going to take you to get through these things because we haven't used these exercises for the class yet. So it might take a long time. It might not. So if you blaze through it, keep going, keep writing some of the code for the other exercises. And again, post questions in Piazza. So cool. I'm going to hang around. The mentors will probably hang around for a little while too. So if you want to start working on this stuff, if you have questions about the lecture for today, please do hang around, or even homework from last time, hang around and we'll get those answered for you. All right. Thanks a lot, everybody. Have a great Saturday and the rest of your weekend.